Okay, we are analyzing the TDS center. We analyzed the two options, this one and that one. And from the energy point of view, this is the better than the other one. So we are going to abide by this option. And now we have to analyze the PV array itself. And we are going to use these numbers. So the tilt is 15 and the DC size is 147. So let's open PV watts. We are in Keene, New Hampshire. The DC system size is 147 kilowatts. The tilt is 15. It's going to be south oriented. And now we look at this elements. Okay, this is the yearly analysis. Can I copy and place it here in the quiz? Yep. So what is the monthly production in January? You have to go to January, AC energy, this one. We have to place it here. And then what is the monthly production in July? This one. And you have to place it there. Okay, piece of cake. We know how to do that. We have done it before, so no problem. But now we have to do this. We have to download the hourly data from PV watts, and we have to include these values. So on PV watts, you know that we have this hourly. So download it and open. Okay. So if you open this file, you will find this. Okay. So I want you to do it to make sure that if you have any trouble doing this, please get back to me or let me know right away, because you are going to do this for the quiz that will start in 30 minutes. Okay, so this is the AC production. Okay, so the last row is the AC system output in watts. So this is the value, this is the figure that we have to introduce there. Okay, so we have 1, 2, 3, 4, 5, 6. And here we have to introduce in the quiz, there are 8 hours. 1, 2, 3, 4, 5, 6, 7, 8. And here we have 1, 2, 3, 4, 5, 6, 7, 8 values. Okay. So the first hour is this value. Don't use decimals, just use the okay, 26,306. Then the second value would be this one. And so on and so forth. Okay, so you have to include here 8 values. This is on January the 1st. Okay, so that's why I'm using because this is the month, 1st is January, day, this is January the 1st. So all these values are from January the 1st, and here we have January the 2nd. We're not going to include 0, so only the 8 values. So there are only 8 hours in which this PV array is producing energy. It makes sense. It's in January. So this is what we have to do now. The next question will be on July the 1st. So on July, there should be more time, more than 8 hours, because we have more hours of sun in July. So we have to go to July the 1st, and then we have to include all these values. So we have to go to July the 1st. So it's the month, it's number 7. Okay, this is July, and this is the day, the 1st, until July the 2nd. I can highlight this. And these are the values that we have to copy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Are there 15 slots? Yeah. So we have from hour 1 until hour 15. So you have to copy these values, 375. The next one is 8,003. So that would be 375. The next one is this one. The third one is 30. The fourth one is 55. And you have to complete this. And finally, you have to upload a PowerPoint with the daily AC production in January the 1st and on January the 1st and on July the 1st. How can we do that? So we have to create a graphic with this. First, on January the 1st, we can highlight this. We have to select all these numbers. So we can insert we can insert this one with bars. I think it will work well. Let's see. And now we have to right click and select data. We have to add a series. So the series name is AC, system output. And the values are the values from the hour 0 until hour 23. Okay. And is this what we want? Not really. Is this the chart that we want for these kind of things? Okay, this is slightly better. So I think you should select one of those graphics, the 2D column. And here, this is the, well, this is at 9, from 8 to 9. Yes, then we have from 9 to 10. Yes, so this is the hourly production. And we can edit this because this is the AC system output, but this is January the 1st. Okay, so here we have from 1 to 24, we have 24 hours, and this is the PV product, the AC production in watts. So we are close to 70,000. This is 66,000. So we are close to 70. And okay, so now we can copy this one. We can go up to the July the 7th. Paste it. We have to change this. This is not January anymore. This is July. And now we have to right click, select data, and we have to edit. We have to select this, we have to edit. And now the name, it doesn't matter. Well, the name is this one, so it doesn't matter. What matters is the series value. So you have to click here on that arrow, and then we have to select these numbers here. Now this is, this is, yeah, automatically it goes to January the 1st. So make sure that you are here, and then you have to select all these values. Okay. So this is the system output. We have more hours, and probably the maximum value is higher than the maximum value that we had in July. In July, I think it was 70,000, and this is 100,000. Okay, so now if you want to compare, click OK. Don't forget to click OK. And now we can copy this here. Okay. And this is but is it good to compare? Well, here we have from 0 to 120, and here we have from 0 to 70,000. Well, that's fine, but we have to look at this. I think it will be better if we change this range. Okay, so if you double click here, here we have the format axis. And here we have the bounds, the minimum and the maximum. The minimum is 0, so that's fine. But if we type here 120,000, yeah, I think this is that gives a better understanding of what we are doing, because now this is clearly less than the maximum value here, is clearly less than the maximum value here, because we have adjusted the scale. Okay, so here we go from 0 to 120, and this is from 0 to 120. So I think this is better. And finally, we have to create a PowerPoint. So we go to create a new PowerPoint, a blank presentation. And the first slide has to be this graphic. And the second slide is this one. Okay. Now I save this, save as final assignment. Well, I want to create a folder quiz 05. If you put your name on it, it will be great. And now I want to go to the quiz. I have to choose a file, and I will select this. Open. And I hope it has worked. Okay. We'll submit the quiz, and let's see what has happened. Well, all questions are wrong because I didn't use the data that we have to use for the quiz, but I want to check that. Okay, so we haven't uploaded this. Why? Upload the PowerPoint first. Well, I don't know. Anyway, this is the first time I try this option of uploading files. Please review. Upload, choose a file. I want to choose this one. Doesn't work. well, I'll figure it out. Anyway, if uploading this doesn't work, just email me with that file, and that will be okay. Okay? But you should be able to upload this here. So I'm going to do it again. Imagine now that we are not in Keene, we are in Florida, in Miami, Florida, sorry. And now we have a different DC system size, let's say 120. And the tilt, let's say 30. Okay, so the first yearly value would be this one, 189, 259, or 260. Doesn't matter, both answers would be correct. The January value is this one, the July value is that one. And now we have to download this Excel file. I don't know, maybe in your Excel version, you won't have this. If you don't have columns and you don't see the last column, the AC system output, remember that we have another option, which is data, text from CSV file. And well, in this case, we don't have this CSV file, but that's another option in the event that you don't have this, because sometimes in other Excel versions, if you just open the file that you download from PV Watts, you don't have all these columns. You have like a text separated by commas, and then you have to open from this CSV. I don't know, if this computer is working well, but when I tried this in my office, it wasn't working. So I had to open this CSV file. Anyway, that's why I want you to do it. And if you have some trouble doing this, just let me know. So those are the values that we have to use in the quiz for January. Now we have to select July. And now we have to create the graphics. So we can insert, I think it was this one, yeah, the first, to the column, this one. Right click, select data. You have to add the series name. Is this the AC system output? And the values from 0 to 23. Okay. And we have to rename, we have to click OK. Okay. And we have to rename this January. Now we can go to July. Here. Again, insert this graphic. Right click, select, add the series name. Well, I will change this, it doesn't matter, but what matters is the series value. So we have to select all those and click OK. And now we can compare. Go up. And we have to adjust the scale. Well, that's interesting because here in Miami, in January, in this grid, this specific grid, we are producing more electricity than in July. Okay, so this can happen. Well, the peak is more, so the peak is close to 90,000 here, and here the peak is close to 80,000. Why? We have more hours, but the temperature, the cell temperature matters here. So sometimes when the cell temperature is too hot, you hinder the AC production. Okay, so don't think that in good weather we can have more, we have more sun for sure. So we will have more PV production. There are other factors, and the cell temperature is one of the factors. Okay, so if the cell temperature is exposed to the sun and it heats up above, I think it's 50 degrees, it stops producing any electricity. Okay, so be careful with that, because in this option, we have the peak production in January is higher than the peak production in July. Anyway, we have to adjust the scale to the highest value. In this case, it's 100,000. So you have to double click here. And here the maximum, it has to be 100,000. Yep. So now we can see the, well, we can draw different conclusions here. So the peak value is higher in January. That's interesting. But what is the total value? I don't know. Here we have ups and downs, and here we have a steady growth and then a steady decline. This might be because we have clouds in January, so we have moments in which we have more production and less, and then more, and then, okay, because that might be because of the clouds. But I would like to see the total, and this is something that I can include in the, well, the total is the January total. This is 15,344. What is the relationship between this and this? If we add up all these values, the total should be something similar to this. Well, this is because of the units. This is kilowatt hours, and here we are analyzing watts. Okay, yeah. So that's why we are not. Yep, we don't have the, yeah, because the units are different. This is watts, the other one are kilowatt hours, and so it will be different. And now we have to prepare the, well, here I can change this title. This is July, Miami, AC, output, watts, and let's make sure that you include the location. And now we can this is January in Miami, this is July in Miami, this is January in Keene, and this is July in Kin. So comparing the total value, yeah, so look at this. In Kin, clearly we can produce more energy in July than in January. This is because probably the temperature is not as high in Kin as it is in Miami. In Miami, we can produce more energy in January than in July. The peak, maybe the total is different. What is the total, by the way? The total, yeah, look at this. They are very similar. 15,344 and 15,685. Okay, so it's slightly higher in July, but they are very, and the peak production over the year is in March. Interesting. Okay, so those are things we need the simulation. We cannot calculate this by hand, and even if you are experienced in that, it's impossible to understand this without the simulation. So it's impossible to understand that we are going to produce as much electricity in January as in July, and it's impossible to understand, to guess that the peak production will happen in March. Okay? So that's why we need the simulation. We have experience, and we can use the experience to understand or to know what the best angle is at each location. But then when we want to extract conclusions about the peak load, the month, we need a simulation. So we cannot do this without this software. Okay, so this is it. So far, you have to do this on you have to read the location, or you have to open the quiz. You have to read the location where we are working, and then you have to submit these two graphics. But for the final assignment, after analyzing this, after analyzing the passive solar heat gain, we are going to work with this. Okay, so we are going to work with the PV watts daily analysis in January and July. You have to work with the same options that you have been working here. So if it's, you have to use the open rack with 15 degrees or 16, I don't know, each one has to use a different number here. Okay, and now we need this. You have to create graphics of daily energy AC production. So we have to include here probably, if we can place both graphics. Like this. We can copy. And we can include this on our report. But I want more. This is a day, so this is January the 1st and this is July the 1st. But for this exercise, I want more. So you have to work with this. If we are in Kin, we can create another graphic. And I want this to be January. So we're not using a daily analysis, we're using a monthly analysis, but looking at different days. So we have to select data, and now we have to edit. And here, the series value, I have to select January. But if I want to do this, yeah, first I need to know where January starts and where January ends. Okay, so I start here, and then I have to go all the way down up to month number 2. So here we have January the 31st, and we click OK, and let's see what we have done with the graphic. Yeah, that's it. Probably in this kind of graphic, we can extend the size, yeah, so that would be better. Okay, so this is not January the 1st, this is just January. And here we can understand that on cloudy days, we don't have any production, or the production is minimum. But on sunny January days, we have this. Okay, so we have a peak of almost 100,000 watts, and the minimum production is around, this is 20, yeah, it's around 7 or 8,000. So this is the maximum and the minimum AC production in January. What happens in July? So we have to do the same in July. Okay, we can go down to July. Here. So we can paste this, and now we have to select data. We have to edit, select all these, and make sure that we go back to July again. Yep, this is July the 1st, and we have to go all the way down until July the 31st. Very good. This is July. Okay, this is January and July. We do have cloudy days in July, as you can see here. Okay, so there are a couple of cloudy days in July, but yeah, and I think it's good that the production is adjusted. We have the same scale, 120 and 120, so we can see the peak production. There's not, so look at the peak production in January is almost as high as in July. It's around 100,000. Well, here it surpasses the 100,000. But when it comes to the peak production, it's not a huge difference. But the thickness of this element, yeah, so it gives us the idea that we have a lot of hours, a lot of sun hours here, but here we have fewer sun hours. So that's why the thickness of these charts, or this set of values or series of values, well, this is thinner than that one. That depends on the number of hours that we have in July. Okay, so that would be this is the first part of the report, and this is the second part of that report. And finally, this is what we did on Monday. So on Monday, you have to analyze heating and cooling loads. And then you have to do this with Revit, and then you have to analyze the three spaces here. So next week, we will talk about the heating and cooling loads analysis, because in Revit, we have these two options. I have found out that we can use Insight in Revit. So let me open